Hi, my name is Kiran Baburaj. Today we are diving into one of the most fundamental data structures in computer science, the linked list. A linked list is a linear data structure used to store a collection of elements. Unlike arrays, where elements are stored in continuous memory locations, linked lists use nodes that are scattered in the memory but connected through pointers. So, what is a node? Each node in a linked list has two parts: a data, the value or element stored in the node, and a pointer, a reference to the next node in the sequence. There are three main types of linked list. The first one is single linked list. Each node points only to the next node, and double linked list. Each node has two pointers, one to the next node and one to the previous node. And finally, the circular linked list. The last node points back to the first node, forming a loop. You can see the dynamic memory allocation in a linked list. It is not in continuous nature, so that it's more memory efficient. Alright, how to insert nodes in the beginning, middle and end of a linked list? We will visualize and explain the process in detail. To insert new node at the beginning, we follow three simple steps. First, create a new node with the desired value. Here it's 0. Second, point the new node to the current first node, which is the node 1. And finally, update the head pointer to point the new node. Next, to insert the node in the middle, we need to traverse the list to find the correct position. Start from the head and move through each node until we reach the node 2. Once we have found the correct position, we have to create the new node with value 3. Next, point the new node to the next node, which is node 4, and update the previous node's pointer, that is node 2, to point to the new node. That's it. Finally, to insert the node at the end, we need to traverse the list to reach the last node, which is node 3. Once we have reached the end, we follow three simple steps. First, create the new node with value 4, then point the last node to the new node, and finally point the new node to null, indicating the end of the list. Alright, now it's time for deletion of the nodes. We can either delete from the beginning or at the end, or even with a specified value. To delete the first node, first we have to mark the first node for deletion. Next, update the head pointer to point to the next node. And finally, remove the first node and free its memory. To delete a specific value, we first need to traverse the list to find the node containing the value. So let's start from the head and move to each node until we find the value 4. Once we found the node, we follow these steps. Update the previous node's next pointer to skip the node being deleted, and remove the node and free its memory. Similarly, to delete the last node, we need to traverse the list to reach the second last node. Once we have reached the second last node, we follow these steps, that is, updating the second last node's next pointer to null, and remove the last node and free its memory. Let's implement a linked list using the Python. So first we define a node class. Each node is initialized with a data, that is a value, and a next pointer to set none, indicating the end of the list. Next, let's look at the linked list class. This class manages the nodes and provides methods to manipulate the list. So the head attribute points to the first node in the list. If the list is empty, head is none. To add nodes to the list, we use append method. This method adds a node at the end of the list. We create a new node with the given data. If the list is empty, we set the new node as the head. Otherwise, we traverse to the last node and link the new node to it. That's how appending the data to the linked list is carried out. Now let's implement the print list method. This method prints all the nodes in the list from the head to the end. First we check if the list is empty. If it is, we print a message and exit. If the list is not empty, we start from the head and traverse the list. For each node, we print its data and move to the next node. And finally, we print none to indicate the end of the list. Let's visually implement a linked list and see how nodes are appended to the list. So let's start with an empty linked list. In this case, head points is set to none, indicating that there are no nodes in the list. Append the first node 10, which becomes the head, and append the second node 20, connecting it to the first node, and appending the third node, connecting it to the second node. That's how linked list grows dynamically as the new nodes are added. So let's explore the key characteristics of linked list. Linked list can grow or shrink during the runtime. Memory is allocated only when needed, with nodes scattered and connected by the pointers. And inserting a node into the list, just update the pointers, no need to shift the entire elements like an array. And deleting the node is just as easy, updating the pointers and free the memory. But it has no random access. Linked list does not support random access. To find a node, you must traverse from the start. Alright, further moving on to the time complexity. Accessing then searching the elements takes order of n because traversal from the head is required. Insertion or deletion at the head is order of 1 since it involves only updating the pointers. Insertion or deletion at the end is order of n since traversal to the last node is required. So the linked lists are used for the dynamic memory allocation and used for the implementation of stacks and queues and the undo functionalities. I hope you enjoyed the video. Don't forget to like and subscribe. Happy coding. Thank you.